Hello everyone, welcome to Code and Learn. In this video, we are going to write the setup for enabling integration testing in our project. So if you remember, we are using Tilt to create a local cluster where we deploy our service with all its requirements like the DB. Now we are going to use this cluster to perform our integration testing, which is one of the reasons we added Tilt. So what we are going to do is write some code that will port forward requests that we make from our tests to this cluster and to our API server deployment, and then assert on the responses. For that, the first thing we need to do is write some code to create a port forward to a Kubernetes service. So let's create a directory called test. This will hold our integration test. Inside it, I'm going to create a file called portforward.go. I will call it package test. When we write our integration test, we will use build tags to target these tests. But for now, let's just proceed ahead and write the port forwarding code. If you don't know about port forwarding, I will add a link in the video description which will give you an idea of what is port forwarding in Kubernetes. Let us create a function called forward, which will be used to create a port forward. It's going to be a test helper, so I'm going to do testing.t. Or let's accept the interface testing.tb to port forward. We will need the service namespace. So let's say service namespace, which is a string, service name, which is again a string, and the container port that we want to create the port forward to. It's going to be int. This function is going to return a string that is a connection URL which has the port forward setup. So if you make a request to that URL, that will reach our service inside the local Kubernetes cluster. First thing I do is declare it a helper, that is a test helper. Now to create a Kubernetes port forward from Go code, we are going to use the k8s library or Kubernetes packages. First thing we need to do is load the client config that we will use to create the port forward. First, we load the loading rules. For this, we will use the package client cmd, which is exported by the Kubernetes client Go tools packages. What we want to get is a default config. So we will get the new default client config loading rules. We don't have this package imported to the project, so let's get this. We will import the latest by using go get -u and the package name. And let's do a go mod id. Cool, now that package should be imported. After loading the rules, let us get the client configs. So loading client config. Again, we will use the client cmd and get new non-interactive default loading client config. This creates a client config using in the past and context name. So we will pass the loading rules and then an empty override. So we are using default client configs. Let me close this sidebar so that we have some real estate. So basically we are using the default, and as you can see, since we are doing it from the code, we are using non-interactive loading client configs. Then let's create the client config, error, loading client config, and get the client config. We assert that there's no error while loading it, so we can say no error t, error. Now we will use the speedy transport protocol to create a transport. Speedy is a protocol developed by Google. You can read more about it in the video description. So I'm going to say transport upgrader error is equal to speedy. We are going to use client go transport speedy and then get the round tripper passing the client config. Again, assert that there is no error, so require no error t, error. I'm not going to bother about these because after we have written the code, we can just pull the dependencies by using go mod id. Next, we need to provide buffers for errors and output. So any error that the client gets and one to print the output. So var buff error buff out bytes dot buffer. Then we also need to create two channels. One is the stop channel. I will just call it stop chan. Make a buffer channel of 1. Then we will add read chan, same as before, channel of empty structs and capacity 1. Now before proceeding, we need to get a free port on our current machine where the port forwarding can be set. For that, we will create another helper function called freeport. Freeport will return a random free port on our localhost. Returns the free port. So again, a helper function tb.helper. Now we are going to use the net.listen function to get the free port. First, let us get the listener net.listen on to TCP and localhost 0. Again, require no error. So what listen will do is listen on the address we passed, then it's simple as I can do fp or free port, which is simple as calling listener address and then asserting that it's a pointer to TCP address and then getting the port. Then we will close the listener because the job of the listener was just to provide a free port. In the end, return the free port. Just to make the IDE happy, let's do go mod IDE. So you can see the dependencies have been pulled. Back to our code. Let me get the free port, fp, which is free port, pass t. That should give us the free port. Now let's get the host for Kubernetes. We will use string.trim prefix and remove the HTTPS protocol from the client config host. So I can just do client config host and then HTTPS and this. Now let's create the path for the port forward API. These are all Kubernetes APIs. So Kubernetes API v1 namespace or the namespace in which we are going to create the port forward. Namespace is something that we accept as an argument to this function. Then pods, which will be the pod running in the namespace for our service, and then port forward. First is service name. We are going to create a function called random pod to get the pod inside the namespace, which will accept t client config, service namespace, and service name, and on that pod we will get the name. So that will be our port forwarding request API URL. Now let's write the function to get a random pod in the given service name for a given service. Random pod, which accepts tb, which is an interface, testing.tb, config, which is REST or the REST API provided by Kubernetes, getting the config, service namespace, and service name. Returns a pod, which will be of type core.pod. Core is another package provided by Kubernetes. So let's import that into our project. So it's kh API core v1. First, let us mark this as a helper with tb.helper. For context, we are just going to use t.context or tb.context. Then let's get the kh client set. We will say Kubernetes new config or new for config, pass the passed in REST config, require no error. Next, get the service inside the Kubernetes namespace. We will do get the service error. This can be done through the client set core v1 dot services. For namespace, we will use service namespace, get, pass the context, the name of the service, and then meta.get options. This is another package we need to import. So let's do that. At the top, I will just do meta, which is kh API machinery package APIs meta v1. Now, before moving forward, let's quickly do a go mod IDE. Back to our code. First thing we do, require no error, tb error, and then we expect the service to be not null. So we will do require not null, which is tb service. So the service object should be not null if we found the service in the given namespace. Next, we will use the labels defined on the service. First, let us create the label slice. Next, we will range through the service spec to get the labels for key, value, range, service, .spec, .selector. If you're not familiar with the Kubernetes construct, just Google them and you should get an idea of what we are doing here. Labels, append to labels with key and value. Now get all the pods matching the service labels. So pods, use the client set core v1 dot pods. Again, the service namespace list, that is list all the pods, meta dot list option. Pass the label selectors. We need to do strings dot join labels and just join with a comma. Let's limit it to one pod. Again, require no error and require the pod to be not empty. So we will do require not empty t pods tb pods dot items, and in the end return the first pod. So we will do pods items and just access the first item, that is on index 0. So that should give us our random pod. With that done, let us write the rest of the code. Now it's the time to create the port forward finally. So we will use port forwarder dialer. First thing we need to do is get a dialer. Again, we will use the speedy protocol, speedy new dialer, pass in the upgrader, which will upgrade the protocol used to create the port forward to speedy. Then we provide a HTTP client, updating the transport to the transport we had earlier. http.method post, and then the url scheme of the URLs should be https, path should be the path we just created, and host should be the host we again created. We can use it to create a forwarder, port forward, which is again a package exported from the Kubernetes API. So I'm just going to import it here. Let's do it here. So we do port forward dot new, provide the dialer, then the ports, that is the ports we want to create the port forward between, which will be the localhost port and the container port. First is the free port that we created, or FP, and then the container port that we accept as an argument to this function. Pass in the stop channel buffers for output, that is buff out and buff error. Again, require no error. Now let's create a new Go routine to create the port forward so that our current function is not blocked. We will do error forwarder forward ports, which is a method on the forwarder, and require no error t.error. We will use the testing.context.done to block before closing the port forward, for which we will use stop channel. So just closing the stop channel will indicate to the port forwarder that it should be closed. So what we are saying is, until the testing is done, keep the port forwarder working. Now we block the function until we have rechannel, which means that we will block until the port forwarder is ready. And in the end, we will just return the address of the local host where the port forwarder is set, or the port forwarder is set, localhost, and just use the free port, and that's it. Now we are getting an error because we didn't import port forward. For that, let's just do go mod id, and that should fix it. So that's all our port forwarding code. First, we loaded the client config to be used for Kubernetes client. Then we use speedy protocol to create a round tripper or transport and upgrader. Then we set up the required constructs, that is channels and buffered output for port forwarding. We fetch the free port using the free port utility we created, which basically listens on to the localhost for any free port and then returns the port. Then we created the host for the connection using the path, which is the path of the Kubernetes API that we send the request to create the port forward. And finally, we used port forward.new to get the forwarder, and in a separate Go routine, we are using forward ports to create the port forward. In the end, we are returning the address of the port forward. This needs to be corrected to %d because free port is a int value. And that's it. Now let's create a file called news_api_test.go. And this is where we will write our test cases or our integration test. This will again be package test. I'm just going to create a basic first test. News API post, that is to create the news service address, that is the address of the port forward. We will use forward from our helper pass in t. The new service is created in the new service namespace, and the service name is news API service. The container port of the service that we are running is 8080. You can verify it from the deployment YAML, and as you can see, we are specifying a port 8080. So that should create a port forward to the service. Now the URL we want to access is service address /news. Let's create a request that we want to make. HTTP new request with context, pass t.context, http.method post, or let's do it method get the URL, and nil for the request body. I will just say it API get, require no error while creating the request. Let's get the client, which is http.new default client or default client. Make the request client.doRequest, which returns a response and error. So we'll use response error, require no error t.error, assert that the status code return is 200 t http.status ok rest.status code. So that will act as an integration test. I'm just starting with a basic integration test, but you can add more to test the whole API completely. Now let's test our port forward. Before running a test, let me tag these with integration test build tags. I will just do go integration or go build integration test, and same for this. Now in our make file, we will create test integration. For this, we will use the tags to target that particular test. So I can do go test tags, tag we added here, which is integration integration, and then specify our test directory, which is all tests inside the test directory. Let's try it now. Make test integration. This is failing because our cluster is not running. So first let us start Docker. Kubernetes is starting. So let's wait for it to start. Okay, Kubernetes is now running. Let me minimize this. Cluster with tilt. So let's do that. I will add it here. First command is tilt up. So we will say tilt and simply tilt up. And then to bring our deployment down, we will use tilt down. Tilt down. In a command line, let's do make tilt up. So this is starting. Let's wait for it to come up. Okay, so now our deployment is running. In a new terminal, let's try integration test again. Test integration. So as you can see, our port forwarding is not working. I saw that we are providing the wrong namespace for the port forward. So this should be service name space. I've added a timeout of 30 seconds for our integration test to work. And if I run the integration test, it will fail after 30 seconds because a port forwarding is not working. While going through the code, I found the issue was with the path. That is, the API path that we use for Kubernetes to create a port forward. Here, it should be namespaces. With that fix and a cluster running, if we do make test integration, you should see it's passed. So that is basically how you would create a port forward through code and use it for integration testing like we do here. So you can write more test cases for the post, delete, patch endpoints by using this. That's it for this lesson. I hope you enjoyed it. If you have any questions, please post a comment under the video or reach out to our Discord server. Until next time, happy coding.